C. Now this carbon here will be carrying, this hydrogen has moved up here. Okay, let me see. Oh, sorry, this is OH and H. So this goes up here, the oxygen connects them now. So since this has moved up here, the OH is now here, then the oxygen is what is connecting everything together. So the oxygen is carrying this carbon atom with hydrogen and OH. Then this carbon here is carrying hydrogen and this whole thing. This whole thing can be written as CH2OH. So that means that the oxygen now connects these two together, whereby this one is carrying H and this one is carrying H and OH. So this carries HOH, while this carries H, CH2OH and H. You can try to put it any way you want to actually. So this now shows that your triglyceraldehyde has a triangular structure here. So this is your structure for triglyceraldehyde in its cyclic form. Also, it could either be an alpha or a beta structure. Remember I said it's a three-dimensional structure. So it actually exists in three forms. This is the first one, the straight chain. This is the second one in its alpha form, where you have OH down here and H up here. Then the third dimension is where you have OH up here and H down here. So that's because this compound tend to rotate themselves. So the same way when this one is up here, is known as a beta triglyceraldehyde. So this is the straight form, the alpha form, and the beta form. That's this three-dimensional structure. And that's it for triglyceraldehyde. Now I shall move into ribose sugar. Now ribose sugar is a 5-carbon sugar. There are other types. There is ribose 1,5-diphosphate, not 1,6, please. Okay, so for ribose sugar, now general formula is C5H10O5, and like I said, it will also have a three-dimensional structure. Now the first structure is in a straight form, 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4, 5. So you have OH, H, H, OH, H, OH, H, H, OH, and you have this. Now what you should know is that ribose sugar is also an aldose sugar, that it has the aldehyde functional group. Now this is its structure in a straight form. This is structure in a straight form, but also it can be represented in a three-dimensional structure. So the three-dimensional structure, like I said earlier, is formed when the carbon carrying the functional group reacts with the second to the last carbon. Now this is the carbon carrying the functional group, CHO, while this is the second to the last carbon atom. So when this one reacts with the second to the last one, this OH moves up here, the double bond breaks and connects this to this. So that means that the oxygen now is carrying 1, 2, 3, 4, while this one is carrying the last carbon. So to draw out the structure, it has a like a pentatonic structure, like a, I don't know how to call it, a pentagon. Yes, a pentagon. So this is oxygen carrying this carbon, hydrogen and oxygen, hydroxyl. This other one too is carrying hydrogen and OH. The next carbon is carrying OH and hydrogen. The next carbon, which is the last one now, is carrying hydrogen and this CH2OH. So you have CH2OH and then you have hydrogen, then you connect it. Now this is one structure, and because the OH is down, this will be the alpha ribose structure. But then when the OH comes up here, now you're not going to have a beta structure. That is three-dimensional structure. So this is Lankotheory Educational Service. Once again, do not forget, make sure you check our website. Now we shall continue from here next class, and we shall move into your hexose sugar, which is 6-carbon monosaccharides.